Okay, this is section 7-5, 3 properties of logarithms. So now that you kind of have an idea of what a logarithm is, you understand how to solve logarithms, you understand what logarithms are asking, you understand that they're the inverses of exponential functions. We're going to look at 3 properties of logarithms, basically 3 things that you can do to manipulate logs. And these things are going to be useful in coming sections, so it's very important that we get some practice and really understand what's going on. So the first of the 3 properties is called the product property. And I think we all know that product is math talk for multiply, so it shouldn't surprise you that this property has some multiplication in it. And here's what the property says. It says if I have the log, it doesn't matter what the base is, so I'll make it base b, as in it could be base 10, it could be base 100, it could be base e, of a multiply problem, say m times n. That can be expanded into 2 logarithms. The log of m plus the log of n. Okay, and let me show you what I mean with a specific example. So let's say I had the log of 3 times 7. What I'm saying, now notice this is of course log base 10 because I didn't write a base there, it's the common log. That could be expanded to the log of 3 plus the log of 7. So this multiply, this product, expands to the adding of 2 logs. And to convince you that that works, if I enter the log of 3 times 7 on my calculator, of course that's really the log of 21. If I enter that on my calculator, I get approximately 1.32. Now, if I enter the log of 3 on my calculator, I end up with 0.477, and I am kind of rounding off here. It's a much longer decimal than that. And if I do the log of 7, I end up with 0.845. And if I add those together, I do in fact get 1.32. So it all works out. And this property is really based on some of your rules for exponents. I won't get into actually proving to you that it works, but we can at least see with this verification. So multiplies can be expanded to adds. Very much related to that is the quotient property. And it shouldn't surprise you that this one involves some division and is very, very similar. And it says the log doesn't matter the base of a division problem or a fraction. This one can be expanded, well, you can almost guess. If a multiply expands to add, then this one, a divide, is going to expand to subtraction. So it also expands into 2 logs, but with a minus sign. And I'll leave this one for you on your own to verify if you need some convincing on that, but it does indeed work. And then the third one, the last one, is called the power property. And this one probably is the most useful. This is the one that we're going to use the most in the coming sections. But what it says is if you have the log, again, I don't care about the base, it can be base whatever you want, of some power, m to the n, this n can be moved out in front so that we would have n log base b of m. In other words, and I think this one, just to help you understand this one, let me give you an example. Let's say I had the log base 2 of 4 squared. The log base 2 of 4 squared. That would be the same thing as taking the 2 and putting it out front and log base 2 of 4. And actually we can kind of do these in our head and convince ourselves that these work, because this is really the log base 2 of 16, which is 4, because 2 to the 4th is 16. And this one over here is 2 times. Now, the log base 2 of 4, what power do I raise 2 to get 4? 2. This one is also 4. So it all works out. So we have the product property, the quotient property, and the power property. And all the problems that we're going to do in this section are really just going to revolve around the idea of you getting comfortable with these. So these problems aren't necessarily ones that'll come up like maybe in future math classes, but they are going to help you be comfortable with these properties, and you need to be comfortable with these properties. So onto some real problems here. All right, so for this first problem, we're going to say use log base 4 of 3 is approximately 0.792, and log base 4 of 7 is approximately 1.404 to evaluate. And the first one we'll do is the log base 4 of 3 over 7. Now, I do not care what the log base 4 of 3 over 7 is. I don't really care about the answer, but what I am interested is if we can take the information that we have, the information that was provided here, and combine that with what we know about manipulating logarithms, those three properties, and see if we can come to some conclusion as to what we have here. And the way you want to approach this is I look at this and I see there's division, and I know I can expand that. I know that the quotient property says that this is log base 4 of 3 minus log base 4 of 7. Now, why does that help me? Well, that helps me because I know what the log base 4 of 3 is. The problem told me it was 0.792. And the problem also told me that the log base 4 of 7 was about 1.404. And if I subtract those two numbers, I end up with negative 0.612. And that is a good approximation of the log base 4 of 3 over 7. So again, I don't care what the answer is, but I am interested in can I use those properties can I think about them and use them to help me find that answer. But the answer itself I don't care so much about. So how about something like this? I do the log base 4 of 21. Well, I know about the log of 3, and I know about the log of 7. The problem told me about those, but I have no clue about anything with the log of 21. Except I realize something, that 21 is really 3 times 7, right? And I know about log of 3 and log of 7, and I know that multiply can be expanded. Log base 4 of 3, and it expands to addition. Log base 4 of 7. And so it's kind of the same thing we did before. I know the log of 3 is 0.792. I know the log of 7 is 1.404. And I can add those together and get 2.196. Again, I don't care about the answer. What I really care about is my understanding of the expanding using the properties. Okay, one last example to use the last property. If I had the log base 4 of 49. Okay, now again, I don't care what the log base 4 of 49 is, but I want to see if I can use my properties to figure it out. So I'm not sure what to do with this because, again, I don't know about 49. I only know about the log of 3 and log of 7. But you know what? 49 is really 7 squared. It's really 7 squared. And according to this, when I have the log base 4 of a power, I can take that power and I can move it out front. 2 times the log base 4 of 7. And guess what? I know what the log base 4 of 7 is because it gave it to me in the problem. And I really have 2 times 1.404. And that would give me 2.808. And now I can tell you, now I know what the log base 4 of 49 is approximately. Now you might be saying, wait, isn't there another way to do that problem? And the answer is yes. You didn't have to use the power property on that. You could have used the product property. You could have said that, well, this is really log base 4 of 7 times 7, because 7 times 7 is the same as 7 squared. And if you did that, you could say, well, this expands to log base 4 of 7 plus log base 4 of 7. And if you had done that, you would also have 1.404 plus 1.404, and you would have still gotten 2.808. So the power property is almost just almost an application of the product property, or it comes right from it. So you'll see some problems like that in your assignment. Now, in addition to that, you will see some problems where the directions are expand. And again, the goal is to get you comfortable working with these properties. So you might see number 1, the log of 5x. And you would say, well, gee, I see a multiply there, right? That's 5 times x, and I know that multiply expands to addition. So and when I say expand, that means get bigger, so I'm trying to take something small and write it as big as possible using my properties, right? And so another one, how about log of 3x to the 4th? Now notice with this guy, there are two things going on here. I've got a multiply right there, and I've also got a power. So the question then is, which one do I do first? Do I bring the power out front, or I deal with the multiply? And the answer to that has to do with, well, this 4 that's right here, who does that 4 go with? Is it the 3, is it the x, or is it both? And the answer is it goes with the x. It's 3 times x to the 4th. If it went with both, I'd have to have parentheses. So I am going to first deal with the multiply, and I'm going to expand it to the log of 3 plus the log of x to the 4th. Then I will leave the log of 3 alone, but I will further expand this guy to 4 log x. So I'm applying both properties. If I had dealt with that exponent, if I had dealt with the 4 first, then there would also be a 4 out here, and you know what, that might be a problem because the 3 was never raised to the 4th power. Okay, let's try another one here. Let's do this one. Let's do the log, a very similar problem. Let's do the log of 3x to the 4th. Notice it's the same problem, but I added some parentheses this time. So both of these are raised to the 4th power. And you know what? I know how to play with this. I know that I can distribute this exponent. So I really have the log of 3 to the 4th times x to the 4th. And both of these are going to get a 4th power applied to them. So I know multiply expands to add log of 3 to the 4th plus log of x to the 4th. And then I'll deal with my powers. So 4 comes out front, log 3 plus 4 log x. Notice in this answer, it's a very similar answer, except both of them end up having a 4 because both were raised to the 4th power. Okay, so I will tell you that these expand problems do take some practice because they're all a little bit different, and if you don't do a lot of them, you will definitely be riding the struggle bus with this. Let's try one last expand problem. We'll do log, and the base doesn't matter, so I'll just change this one to log base 6 just to be different, I guess. Log of 5x over y. Well, again, I've got two things going on. I've got a multiply and I've got a divide, and both of those things expand. So as far as the order, probably the easiest thing to do is to deal with the divide first. And then I can get that out of there and deal with the multiply. So what I would do is, I know that divide expands to subtraction. So log base 6 of 5x, and here's the divide expands to subtract over log base 6 of y. Now, why do I deal with that subtraction first? Well, I know that the next step is to make this log of 5 plus log of x, and it's a lot easier to do that right here if I don't have to worry about the divide being there. If I have to worry about the divide being there, then it just makes things a little more confusing. And there's my final expansion, and it is now as big as it can get. I've taken my condensed log and expanded it big. And again, remember, the goal here is to just get comfortable working with these logarithms. Okay, I've got just a little bit of time left, so I'm just going to introduce you to the next type of problem, though you'll probably see some more of these in the next assignment, and that is condensing. So if you have a condensed problem, you're going to go the exact opposite way. If I had the log of 5 plus the log of x, you would say, oh, well, this is expanded, and I know that an add would condense into multiplication. It's the log of 5x. See, I think before I gave you the log of 5x and had you expand, and now we're just going the exact opposite way. Again, the goal is to increase your comfort with these problems. Okay, one last example really quickly here. If I had 2 log x, I know that that 2 probably was an exponent when it was expanded, so to condense it, I'd move it back. Log of x squared. I know we'll need to do more of these problems, so we'll see some more stuff tomorrow. Until then, have a good day.